Hi there. In this video, we will learn about implicit and explicit attribute relationship. Understanding of this is very important for data analysis and profiling. So let us look at it with an example. Here is a simple data model consisting of two tables. With very little training, you can identify the cardinality between these tables. Here, the diagram denotes that a customer can have multiple sales, but one sale is tied to only one customer. We can verify this by running a query in the AdventureWorks sample database. Here I have written a query that joins the fact sales table with the customer dimension on customer key. In the select clause, I am returning a simple count distinct of customer key as well as a count distinct of the sales orders. So let us see what this query returns. Now, you can look at the result and see for yourself that the number of customers are way less than the number of sales orders. There are 18,000 customers, whereas there are 27,000 sale orders. This supports what is represented here in the data model, which shows that one customer can have multiple sales. However, one sale is tied only to one customer. A relationship such as this, which is exposed through a data model and occurs across two or more tables, is called an explicit relationship. This is because the relationship can be easily identified through a primary key foreign key relationship across a table. However, we also need to be aware of something called as a implicit attribute relationship. Let us look at an example for that. Here, I have a simple select query that returns the email address and the address line from the customer dimension. Please do note that I'm just using one table here. And in the result set, we have the email address and address line 1. And based on the observation, it seems that the email address and address line 1 are almost a 1:1 relationship. In other words, for every unique email ID, we have a unique address. And as I scroll down, this observation seems to hold good because I do not see any resulting values. However, we shouldn't stop our observation just based on visual cues. We should run some queries, we should run numbers to make sure that that observation is true. To do that, I have some additional queries here. So the first query that I'm going to execute is against the customer dimension, but I'll be doing a count distinct of address line. So let me run this, and I see 12,797 records that are unique addresses. Let me do a count distinct of the email address now. Now, as you can see, there are 18,484. Clearly, there are more email IDs than address line. Now, let me write another query. Here, I am grouping the result set by the column that had the least count. In this case, it was the address line 1. And I'm aggregating, or in other words, I'm doing a count distinct of email address. You can see in the result set that there are some addresses that have multiple email IDs, right? So I'll take one of these values and run another query, which is select address line 1 email address from dim customer where address line equal to this. So when I run this, you can see how one address is being referred to by two email IDs. There clearly is a 1:n relationship between these two attributes, but the fact that they are in the same table makes it harder to find them. This is called an implicit relationship. We call it implicit because the relationships are within a table. They are embedded within the same table. Hence, they are not very clearly identifiable. We always have to run queries such as this or use a data profiling tool to be able to understand the relationship between two attributes. Once you have identified the cardinality between these two attributes, you can represent them in a data model such as this. You'll see that it's a lot similar to the earlier one that we saw. However, instead of the table name, here we just have the attributes. So this goes to show that the address is an attribute which can map to multiple email IDs. However, one email ID maps to only one address. Identification of such implicit relationships helps in building hierarchies in your dimension table. To summarize, implicit and explicit relationships are something that are very useful for data analysis. So please remember, and when next time when you're profiling the data, don't just look for explicit relationship, but also document implicit relationships too. Thanks for watching this video. I hope you found it useful.